Yes, good morning students. Again back with the same lesson about the first lesson. So I was just talking about the classification of the maps yesterday. We have classified the maps into two. Which are those? Yes, it is. One is we are dividing it on the basis of scale, and the other one is we are dividing it on the basis of the content and the purpose. So here in the large scale we are having the topographical map. What do you mean by topographical map? Actually we are showing each and everything in this particular topographical map. It may be village, it may be city, it may be any of the hills, mountain, river, or whatever it is. The other one is a cadastral map. This particular cadastral maps are shown to taken to show the individual landed property or and the land registration. So whichever are the private property, these particular things are shown in the cadastral maps. Now what about the small scale maps? Because we have divided it into large scale and the small scale maps. Coming to the wall maps, we are just having the wall maps. It may be the relief feature map, it may be the climatic map, it may be the vegetational map. So we are hanging it on the wall. So those are called the wall maps. Then the atlas, a group of map put together in a book, is called a atlas. So I guess you people all have seen the atlas. So it tells us about the each and every concept. Like it may be we'll be having a political map, we'll be having a physical map, we'll be having a thematic map, etc. So you can just see this. You are having a physical map, you are having a political map, and you are having a thematic map. So we can divide this into three important maps. Now coming to the next is scale. When we are drawing the map, yesterday itself I have told you, we cannot draw the entire thing in one particular small piece of paper. So we will be mentioning the scale over there. Suppose 1 centimeter is equal to 50 kilometer. If I draw a scale of 1 centimeter, that means I have put all that 50 kilometer in 1 centimeter. So the scale should be there in each and every map. The scale of a map denotes the relationship that exists between the length on the map and the actual distance. That's what I said. If I draw 1 centimeter, then it means that I have covered an entire area of 50 kilometers. When I am putting it as 1 centimeter is equal to 50 kilometer. That means that 50 kilometer area is being covered in that 1 centimeter. It can be expressed as the statement of scale, just as I said, or the linear or plane or geographical scale, and the representative fraction or the RF. We call it as RF or the representative fraction. Now what about the statement of scale? Just as I said, 1 centimeter is equal to 50 kilometer. This is statement of scale. Expresses relationship of map to ground in words such as 1 centimeter is equal to 5 kilometers. It means that 2 points from 1A to the second point we are measuring, then we are putting the scale there. Then coming to the linear scale. What is linear scale? Now, linear scale is nothing but this particular part. This is the linear scale. We are showing it in the line. On the line we are showing. Represent the same relationship by means of a straight line divided into parts. Just like we are having on a ruler 1, 2, 3, 4. In the same way, we are having the line there. On that we are marking the scales. This method is used on most of the map because it is possible to read directly from the scale on the ground distance, equivalent of any distance measured on the map. So these are two types. One is the statement scale, the other one is the linear scale. Now I am talking about the representative fraction. Now what is this representative fraction? It is nothing but we are putting it in the form of fractions. It is numerator and denominator we are having. So a fraction is distance on the map. Whatever I am drawing, the distance on the map, divided by distance on the ground. Suppose RF is equal to 20 centimeters divided by 2000 kilometer. It is 20 centimeters divided by 2000 kilometers. 20 centimeters is equal to 2000 kilometers. So when I say this, we can just convert it. So we should remember one particular formula, that is RF is equal to distance on the map divided by distance on the ground. This gives you the complete picture. You can convert it into the centimeters. So now when we are talking about the types of scale, it is we are having the statement scale, we are having the linear scale, and the third one is we are having the RF, that is representative fraction. Now next is the conversion of scale. As I have showed you, one we can just divide it, convert it, keeping the formula RF is equal to distance on the map divided by distance on the ground. So next is the construction of a graphic scale. How can you have a construction on a graphic scale? In the same way, as I have said, we have taken the fraction. Here the graph is being taken. When we take the graph, now for example, we'll be getting a topographical map. It is 42 by 7D will be getting, and on that we have to draw the particular things and then we have to measure it. For example, they may give you 2 points, asking to measure the point using a ruler. They may ask you to use a ruler. At that particular time, you have to take the ruler and you have to measure it. Or else they may give you a pen or a string and they may give you a crooked line. So your thread should go on the same way how the curvings are given, and then you have to measure it. So this is what the measurement will be given. This will be very important because such type of questions are being asked in the board exams. Now next is the measurement, that is the directions. When we are having the direction, as we are knowing, we are having north, south, east and west direction. But still we are having northeast, northwest, southeast and southwest direction. Again it is being divided into SSE. That is, you can just see here, after we divide it into north, south, east and west, we are having northeast, we are having northwest, we are having southwest and southeast. The line which comes in between the northeast and the east is called ENE. The thing which comes in between the north and the northeast are called. So now whatever comes in between the north and the northwest, it is denoted as NNW, and it continues for the entire circle. So these are the sub-circles what we have denoted on the mariner's compass. So this particular representation of the directions should be known to us when we are locating the places or when we are just measuring the places. True north, TN, is nothing but the true north. What is this true north? Now, the direction given by the pole star. Earlier, people used to identify the direction by seeing the pole star. Pole star is to the northern side. So, this particular north side or the direction given by the pole star is called the true north, or it is the north part. As it is nearly at the zenith of the North Pole and so in the northern hemisphere, if we walk in the direction of the pole star, that means we are walking to the northern side. Now what is MN? That is magnetic north. Now when we are pointing the North Pole star, we are moving towards the northern side. But when the magnetic needle points to the northern side, then it is the magnetic north. The topographical map shows both true north as well as the magnetic north. So you can just see here the topographical needle is showing you the north, true north and the magnetic north. Once the textbooks are available to you all, you can go through the lesson again. The magnetic north of the earth is different from its true north. Angle between true north-south line and the magnetic north-south line is called the magnetic declination. So, the angle which comes between the true north and the pole star north and the angle that comes from MN to the pole star, it is called magnetic declination. So, now after knowing the magnetic declination, we are talking about magnetic variation, that is MV. What is this MV now? It is nothing but magnetic north is not fixed, but it changes slowly from time to time. Pole star is fixed, but this magnetic needle, it changes every now and then. So this variation of the magnetic declination is called magnetic variation because it is changing. It is called magnetic variation. Now what about the grid north? Here we are talking about the true north. We are talking about the magnetic north. We are talking about the magnetic variation. Then we are talking about the grid north. Grid north is nothing but it is the imaginary network of equal distant lines printed on a map. As we are knowing, latitudes and longitudes are imaginary. In the same way, you are having this grid north. Okay, these are the imaginary lines that are drawn on the map, or you can just say it as it is the imaginary lines showing the equal distances. Now grid variation, again it is the angle of difference between the true north and the grid north. It is the angle of difference between true north, that is the pole star, and the grid north. So this is about the magnetic declination and magnetic variation. Magnetic declination is nothing but the angle from the true north to the north pole and the angle between the north to the magnetic north. So this is called the magnetic declination, and because this needle is varying every now and then, it is called the magnetic variation. Grid north is nothing but the imaginary line shown to draw the equal distances. So this again says grid variation means the imaginary lines that are between the difference between the true north and the grid north is called the grid variation. Now coming to the bearing. What is bearing? It is an object in the clockwise angle measured from north-south line to a line connecting the observer position with the object. In other words, it is an angle between the object and observer and the north-south line. You can just see the picture here, observer, then the object, then it is. This is particular the bearing. Bearing is nothing but an angle between the object and the observer in the north-south line. An angle between the object and the observer, between the object and the observer in the north-south line. So bearing is the clockwise measurement of the angle formed between north line and the line joining to the other end. So this magnetic bearing with reference to magnetic north-south line is called magnetic bearing, and true bearing is measured with the reference to geographic north-south line. It is called the true bearing. So here we are having the true north, we are having magnetic north, we are having magnetic variation, we are having grid north, we are having grid variation, we are having bearing, we are having magnetic bearing, and also the true bearing. So the conversion of this is already mentioned in the video link which is already sent to you all quite earlier. So this is what about the complete lesson about the map reading of the topographical map reading of 10th standard. So now there are few questions. So what is bearing? Then what is a true grid? Then you have to write what is magnetic declination. Then you should know how can you read or measure a map using a twin. So these are the questions asked every now and then. So go through the lesson properly, understand it, and as I have told, see that you are writing the structured answers of all the lessons that are taught. Then you have to write 8 small answers. So I repeat, 8 small answers and all the structured answers. Learn the answers properly. Till then, take care.